I strongly encourage you to read. If you don't read, you will find there's a lot of information there. You're missing the opportunity to learn some information. So first, I want to see whether everybody understands this equation. You should not memorize it. You should understand it. Raise your hand if you have questions. Because this is a foundation for today's class. 9.6. Any questions? How do we get there? 9.6. Can we get a volunteer to tell us how we get there? You want to try to explain 9.6? Give us a bit explanation what 9.6 does. Okay, go ahead. Thank you.
Will Jack can come up or?
It's up to you. You want to sit there, that's fine too.
Okay. So.
Can you speak louder?
All right then. Equation 9.6 is trying to get a general formula for the partitioning of any integer n into the sum of integers. So we need the first case, which is if n is equal to 1. The only way to write 1 as a sum of integers is just 1 equals to 1. And then in order to arrive at a general expression for any integer n greater than 1, we have to start with the first number that we would write down, which can be any number 1, 2, 3, all the way up to that number n. And then we add to it the way to partition all the numbers that are less than it. So if we have 1 plus whatever our integer is, minus 1, so 1 plus n minus 1, we have to figure out how do we write n minus 1. And for the case where 2 plus n minus 2, we have to figure out how to partition n minus 2. And then we can arrive at this sort of recursive formula, which allows us to write down. So that's where we get the plus f of n minus 1 plus f of n minus 2 all the way down to f of 1 plus 1.
Okay, thank you. Any questions? On Tuesday, I told you, even though the final answer is 2 power n minus 1, you cannot simply say, by observation, this is 1, this is 2, this is 4, this is 8. Therefore, the next must be 16. That doesn't exist. That logic doesn't exist. Okay, you cannot observe finite cases and say the next one must be this one, right? Right. In generally, the whole month, the weather here is below freezing. You cannot say it's always below freezing in West Lafayette, right? In a few weeks, we'll be pretty warm here. Okay. And if you want to derive the closed form, this is a general strategy. You first take 9.6, and you rewrite 9.6 by you taking n minus 1 on the left side. Therefore, you get the second equation here. So you understand this part, this equation, Fn equal to this one, and you simply rewrite the same equation but use n minus 1, and then adjust the right side appropriately. Right? If you agree with the equation on above, you should agree on the equation below. Right? You simply you replace the argument. Then you do subtraction. On the left side, it becomes Fn minus Fn minus 1. On the right side, you cancel the rest and have only Fn minus 1 left. Then you move this term to the right side, so it becomes Fn equal to 2 times Fn minus 1. And then Fn minus 1 is 2 times Fn minus 2. And you keep going until you reach F1. F1 by definition is 1. Therefore, you get 2 power n minus 1. Okay. Any questions? There's another example here, it's a little bit more complex. It asks you how many ones are used. Okay, so the problem is actually integer partition has many variations. we can ask you how many lines are used, right? So in this case, we ask you how many lines are there. So this is 1 line, 2 lines, 4, 8. Another question is how many 1 are used. In that case, you count as 1 and 1, so 1 is used twice. In this case, 1 is used 1, 2, 3, 4, 5 times. For partition is 3. And for 4, 1 is used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 is used 11 times when you partition 4. The question is, for general number n, how many times do you use 1? To solve a problem like this, this is the general strategy. So remember, n is 1 plus n minus 1, right? We've seen that so many times. Now, if I want to count 1, I need to count those ones, right? 1 is used when it is used as a first number. How many 1s are here? So it's actually this will be 1, 1, 1, so many 1s, and then each of the line will add up to n minus 1, right? So suppose I have an equation. Let's say the equation is the Gn is the number of a 1 used to partition n. Suppose Gn is the number. The answer G1 is 1 because to partition 1 we use 1 once, right? We counted G2 is 2. We can also count. Actually, we don't have to, but just G3 is 1, 2, 3, 4, 5 is 5. That's the first few cases. To consider general case, you ask how many 1s are used here. So first, I count how many 1s are used for the first number. I don't worry about the rest. I just count how many 1s are used here. Each line has 1 once, right? If the first number is 1, I obviously use 1 here. But I need to know how many lines. And based on the equation I had earlier, how many lines do we have here? Well, I'm partitioning n minus 1, therefore I have 2 n minus 1 minus 1 lines. Earlier we said there are 2 n minus 1 lines when partitioning n. Right? We just proved that. So now how many lines do we have for partitioning n minus 1? For partitioning n minus 1. Therefore, there are 2 n minus 2 lines here. And every line has 1. So I know for this part I have 2 n minus 2 so many 1s. This is minus 2. How many 1s are used here? I don't know. But I do know my definition is Gn minus 1. So for this part, how many 1s are used here is 2 power minus 2 plus Gn minus 1. This is the first line. This is the rest. Now if the first number is 2, how many 1s are used for the first number? 0 because the first number is 2. But I can have a 1 in the remaining number, so I need to say Gn minus 2. And obviously you can continue to G1. And since the last number is n, if n is larger than 1, when you use n as the first number, it doesn't use 1. Therefore, your equation becomes this way. Any questions? We always follow the same strategy by writing down the first number and then look at what we need to do, right? If the question is how many 2's are used, then you look at the first number and say, I'm not using 2 here, but I'm using 2 here. And how many lines are there? That will be 2 and minus 3 lines. So if you want to count how many 2's are used, then your equation becomes H1 is 0 because you are not using 2 when you partition 1. H2 is 1. You are using 2 once when you partition 2. And then Hn is going to be 2 power n minus 3 plus. You still need to count how many 2's are used here in the second part. Now, depends on whether n itself is 2 or not. If n is 2, right? If n is not 2, so now if you consider n is greater than 2, then the last one is not added. Does this make sense? Good?
Yes.
Okay. Then you can follow similar strategy in deriving the closed form. So you will add them together. Again, you take equation 9.8 and then replace n by n minus 1. You get the second part in 9.9. You subtract these two terms. On the left side becomes Gn minus 1. And on the right side, you have 2 power n minus 2 minus 2n minus 3. Then you get 2 power n minus 3. And the right side, you still have 1 Gn minus 1. And you move that to the right side. So you get Gn equal to 2 power n minus 3 plus 2 times Gn minus 1. It's here. Then you write, you take this equation, this part, and then write it again by replacing using n minus 1. Then you multiply the left side by 2, because I want to cancel this term, 2 Gn minus 1, this term here, and this term here. I want to cancel the right side and left side. So I get 2 Gn minus 1, 4 Gn minus 2, and so on. Then you also need to multiply the right side by 2. Then you add it together, it becomes this way. And then you can replace, finally you'll get this term. As you can imagine, this term will be bigger than 2n minus 1 if n is big, right? But I believe that if you have any question for the derivation, I'll be happy to answer the question after class. Okay. The key here is to understand this equation, 9.8. There are other type of questions. using odd numbers only, and using increasing numbers, and using alternate odd and even, and many cases. So, all right. Any more questions? Any questions? Is it easy? No, nobody asks questions. Raise your hand if you understand completely. Nobody. Okay. So I made a mistake, or maybe many mistakes. Can somebody ask a question? Kyle, you want to help? Can you help the class?
Trying to think of one.
Okay. Seems straightforward so far?
Relatively, yeah.
Okay. Do you think you can handle this? Everybody, do you think you can handle something like this? If you look at the questions in the past exams, integral partition always shows up. Some variation in integral partition always shows up. Some students in the past also say integral partition is the place where you continue 2C4 or you decide to do it again the following semester. Yes, please.
And gn minus gn minus 1, how do you get 2 of n minus 3?
Which one?
It's 9.9.
This way?
Yeah. How do
I do this? Okay. Let me see whether I understand your question. Thank you for asking questions. I'm sure many people appreciate that. Okay. Let me put it side by side so you can still see it. Okay. Let me see whether I understand your question. Your question is, how do you get, so the left side, so basically I have 2n minus 2 plus something. I have a 2n minus 3 plus something, right? And then if I subtract this one, so I get 2n minus 3 plus 2n minus 2 minus 3 plus, and the difference between these two will be gn minus 1. So this will be 2n minus 3 times 2. Do you agree?
how do you get the plus?
Oh, minus, sorry. Thank you. This will be 2n minus 2. 2n minus 2 is 2n minus 3 times 2. Do you agree with me? Okay. Minus 2n minus 3, right? Plus gn minus 1.
Okay.
And then I take 2n minus 3 out, so 2n minus 3, 2 minus 1. So this becomes 2n minus 3 plus gn minus 1. Does that make sense? Did I make a mistake? Okay. Does that answer your question? No. Any other questions? Yes, please.
Could you go over kind of how to translate that into code? Like,
That's what I'm going to do next. Okay. All right, so if there's no more question for the equations, I'm going to write this into code. Okay. Writing into code, there are two types of problems. One problem is implementing the mathematical equation into code. The second problem is you are going to print the partition. What do I mean by that? The first one is, if I give you n, let's say if I give you n, oops, I went too far. If I give you n, you print power 2n minus 1 or something like that. If I give you an equation, actually this is the right equation. So look at the equation here. You write something like the following. I will try to put them side by side. This is a general strategy of writing a recursive function. You look at the terminating condition. So your terminating condition is if n is 1, then you return 1. That's the first part of the equation. Right? Does that make sense so far? Otherwise, you are going to do the following. You'll say integer sum equal to 0. Remember, once you say return, the rest of the function will not run, right? So if you are here, that means n is not 1. Then you will say integer for iter equal to 1. You can start with n minus 1, okay, equal to n minus 1. So I'm translating the mathematical equation into the code, right? If you look at this, I go from n minus 1, n minus 2 to 1. So I go from n minus 1 to 1, decrementing that variable. And every time I call the function and I add them to the sum. I have the last one here, this one. So I have to add that one here, and I return. So the function is this way. Any questions? A more interesting problem is to ask you to actually print all the partitions. Right. But let's solve this problem first. Does this make sense? If you want to implement another one, let me. Oh, why do I always press the wrong key? Let's say you want to consider this case. You want to consider this case. Then you will write the following. First, I'm going to create a power function as a power 2. If n is 0, return 1. Right? If you have a power and the power is 0, the result is 1. Otherwise, you're going to return, I'm going to use recursive function here again. 2, let me do a temp, equal to power 2 n minus 1. Right? That is the definition of power. If 2 times, then you reduce the power by 1, and eventually it becomes 0, then you get a 2, assuming n is larger than. So I've written the function of power, then I can write the function g. So by definition, if n is 1, this function will return 1. Right? Otherwise, I will say integer sum equal to power 2 n minus 2. Then I have the iteration here. I'm going to just copy paste. Notice I don't increment sum at the end because there's no plus 1 at the end. After G1, yes.
Do I not need to ask if n is equal to 2?
N equal to 2 should be handled directly, right? Okay. So if n is equal to 2, then this one, so let's run this program, okay? If n is equal to 2, this one is false. Agree? Then this one, 2 minus 2 is 1, so sum is 1 if n is 2. Do you agree?
Yeah.
Okay? Then come here. This iterator start with 1. Alright? N is 2, so start with 1. N is greater or equal to 1, so you will enter this. Okay? So is 1. Then you will call sum equal plus G1. Right? And what is G1? 1. So it's equivalent to sum plus equal to 1, and that makes sum is 2, because it was 1 earlier. Right? So then you return sum, and when number n is 2, how many 1s are you using? 2. 1 plus 1. Does that make sense?
Yeah.
Okay. Any more questions? If there's no more question, then I'm going to explain. Okay, I guess I should show this slide. If people are watching video. Okay. So if you are watching video, then you may want to pause here. Yes, go ahead. A question?
Yeah, so by adding power 2 into that, what did you change about the actual functionality of the function? Like, what does it do?
Oh, what do you mean, what does it do? I didn't answer the question.
Like, versus your original function g, what does it now do that you added power 2 into it? No. So that's not supposed to be g.
For g, I'm implementing this function. Okay, I don't think I answered your question. Can you say it again? I have a power 2 here,
Yeah.
right?
Yeah.
Okay, so what's your question?
Okay, never mind. I got it now.
What?
No, I got it now.
Okay.
That's
This is a different problem, right? Earlier when we did f, f asks you how many lines, right? And g asks you how many ones. Does that make sense?
Yep.
Okay. All right. Any other questions? So next problem is, instead of simply say how many are being used, I'm going to print them. I'm going to print something like the following. Like this. This is a problem where recursion is much easier than loop. Why is that? Because you can see sometimes you print 4, sometimes you print 3, sometimes you print 1. It's not very obvious how many iterations you need. Right? When you have a problem where you don't really know how many iterations you need, recursion, think about recursion. Sometimes it's much easier to do this by recursion. So this is the strategy I'm going to take. The strategy is I'm going to write a function, some kind of function. Let's say I'm going to print partition. And the strategy is what's the number left? If the number is 0, that means we are done. We don't have anything left, so we are going to print. Otherwise, if we reach here, that means left is not 0. Right, by definition. Or I should say return. If it's 0, we have finished the partition. There's nothing else we can do. So that's a terminating condition.
What is left?
Is what's the number I'm going to partition. So if I use 1, I have n minus 1 left. If the first number I use is 3, I have n minus 3 left. Does that make sense? Okay?
So it is n basically.
It starts with n, yes. Then if left is not 0, what's the first number I can use? Going back to the method we always use. So this is what's left, right? Start with n. What's the first number I can use? The first number can be 1, 2, 2. What is left? Maybe I should not write left. Let me write n. Maybe that's confusing. Sorry about that. Let me do it again. Okay. Let me redo it. Okay. So I want to say the following. I want to first I write void. Okay. Maybe we want to change that. N. We may need something else. I will talk about that in a moment. Okay? N is the number to partition. If n is 0, then nothing else to add. Then we're done. Right? You cannot partition 0. Otherwise, if you get here, that means n is 1 or larger. So what can be the first number to use? If you look at this figure, we have seen that so many times. If you have n, what's the first number you can use? What's the first number you can use?
1,
1,
2,
2,
3, 4, to n.
to n. And which suggests what you should do here. 1, right? The first number you can use is 1, 2, 3, 4, 5 to n. That means it's a loop. Does that make sense? Of course, you need to declare the variable. You start with 1. If you use the first number, what's left? Oh, I should say partition. Why do I say print? I have something else. Okay, but let's start with that. If the first number is 3, I have used 3. I have n minus 3 left. Right, so this is a direct translation from this, what we wrote earlier. We have a few details we need to fill in. But that's pretty much the translation from this figure, right? We get n. The first number can be 1, 2, 3, 4, 5 to n. So we have a loop there. And once we use the number, how much do we have left? N minus that number. Right? Make sense so far? Okay. So we have some additional stuff to fill in. We want to have an array to remember which number we are using. This array stores the number used so far. So what does that mean? If you look at this figure again, when you use 1 as the first number, you want to remember you are using 1. Because I'm going to print, I have to remember which number I'm using. If your first number is 2, you want to remember the first number you are using 2. And why is it an array? Because I need to print each line has a couple numbers to print, right? Come back here. If I use 1, I want to remember I have used 1. So when I print, I know I'm going to print 1. If I use 2, I know I'm using 2. So I'm going to print 2. I need a place to store what I have done so far. Otherwise, when I finish, I don't have any information. Does that make sense? How big is an array? 4. What's the general rule? If I want to partition number n, how big is the array? What's the maximum number I need to use? N. When everything is 1, the array size is n, right? So I know the size of ARR is the original number to partition, right? So when you call this function, let's say you call this function in another function. Suppose you use this main, all right? Then somehow you find n is the number to partition. You probably come from ARGV, right? And then you will do the following. You will say integer of course, if you do malloc, you need to free later. Then you call print n. Right? If you use 1 only, the size of the array is the number you want to partition. Does that make sense? Make sense? Question? Good? Okay. Now if you come here, look at this picture again. You look at this picture so many times. If I use 1, let me draw it in a different way. So I am going to remember which number I use. This will be stored in an array. So this index 0 is going to store 1 or 2 or 3 and so on. So after I finish the first, I need to worry about the rest, right? This will be n minus 1. And n minus 1, recursively, this one can start with 1 or 2 and so on, 3 to n minus 1. Right? I want to remember that number because later I will need to print. Then where should I store it? I should store in index 1. So the first number is stored here, the second number is stored here. The third number is stored here. That means every time I want to partition using a number, I have an index, and that index has to increment. So this number will be, I will pass that array. Why is that the case? Why is the for loop that over there on line 15? Because first means the first number I'm using. After I use the one number, I need to move the index to the next one. So what it means is, here I'm going to say, I remember the number I'm using. Then I need to move the index to the next one so that I can remember the next number I'm using. U star here will be 0. Yes, please.
Is index reflect the depth of the
Recursion, yes, index means the depth of recursion. You increment index each time you add one more number into the array. This is another example of using the call stack to remember, because when you finish this one, you start moving back. Then you remember your index earlier. So that is using call stack to remember the index. Notice that I'm not changing it. I'm just adding one for the next level. It is wrong if you do index plus plus, because that way you are changing it. And when you pass from the call stack, it's a different number. So you want to keep it. So we have something here. Now I will write how many numbers are you using is determined by how far you go in your recursion. So going back to this example, sometimes you use 4 numbers, sometimes you use 3, sometimes you use 2, sometimes you use 1. So you have to remember how many numbers you are using. And how do you remember that? It's actually very nicely is remembered by your argument index. You start with index 0 when you call it in the main function. You start with index 0. And every time you add one number, you increment that by 1. Or not increment, you increase 1 when you call the next recursive function. I'll give you a bit time to look at this. Then we'll talk about how to understand this by considering a call stack. Yes, please.
I think you already answered this, but why was it n minus first for the first parameter from partition?
Oh, because I have used first. How much do I have left?
Oh, the original value minus first.
Yes. So going back to this picture, right? If the first is 1, I have n minus 1 left. So I'm going to worry about that. If the first is 2, I have n minus 2 left. So basically, this is handled by the loop, right? And this is actually not. This is handled by recursion. Does that answer your question?
Yeah.
Any other questions? Let's see how this works in code stack. I know this is going to be a lot of work if we draw it by code stack, but let me show you. So I have a whole chapter talking about integer partition. Okay, so we understand this function. It's pretty much the same thing as I wrote earlier. Let's say you start with your value n is 4. And we allocate memory, since we did the malloc earlier, as I show you here. We allocate memory. So you will have a memory location in heap memory, so let's say the memory location is 10,000. A return location, and pass that argument as the address of the array. And here I actually use left instead of n. Left means how much number you have left to partition. Oh, I also changed the order. I hope it's okay. So left means what's the number you want to partition. Currently is 4. And the index starts with 0. Then you enter the loop. The loop starts with 1. Right? The first number you use is 1. The first number you use is not 0, because if you use 0, you are not making progress. Right? If you start with 0, the remaining is still n. You're not making progress. So your first number you start has to be 1. So you come here and then write 1. Obviously, n, in this example I call left, is not 0, 0, so I'm going to call the function again inside this loop. And the number you have left is going to be 3, so you are going to call the function, and the next iteration, you have 3. Recursive function call is the same as any other function call. Every time you call a function, you push a frame to the stack, the call stack. Your index now becomes 1. Also, inside the loop, here I say array int equal to the number I'm using. Since array is the address of a heap memory, int start with 0. You change this to 1. That's the first number you use. Then you call the recursive function call. Then the next one, you go to the for loop again. The first value is 1 again. So you change this to 1. That's this change. Then you call the function again. But now your index becomes 2, and what's left is 2, because 4 minus 1 minus 1 is 2. So you can continue this. You should trace through this. Okay? I'm sure it took me longer to write this than it takes you to read it. Alright? So at the end, you find out what's left is 0. There's nothing else to do. So what do? You start printing the array. So you print 1, 1, 1, 1. Then the next step is, since it is 0 here, based on the recursive function, when the number is 0, there's nothing to do. You have done the partition already. So you don't call the function again. And the function ends. What it means is you pop 1 frame, so the top frame is popped. Then you go to the previous function. Now this is important. Look at the return location. You determine where the function will continue. Then you go back to this loop. You start with 1. The next you want to do is 2. Right? You increment. So if you look at this, so you increment your value to 2. However, if the for loop is less than or equal to what's left, you increment to 2, you will not run the for loop again. Therefore, the function has nothing else to do, and you pop again. So it becomes this way. Your call stack, the top frame gets popped again. Now you go back to that line 27. Sure. Which part? This one? Line 27, maybe let me show you line 27. Line 27 is after the function call. You are going to go back to a for loop, right? And what do you do in a for loop? This one says you are going to increment the value. So originally it's 1, now it becomes 2, but you have to check this condition. Left is currently 1. So this condition is false. This condition is false. There's nothing else to do in the function. So you pop the frame again. Does that answer your question? Okay. So now you pop to the previous frame, or I should say the frame below. What's left is 2. And you increment value. So now the value is 2, and you also change this into 2. Because inside the loop, we assign this. So now it becomes 2. Notice the index. Index will put the value in the correct place. Because if val is 2, the current index is 2. So your change is to 2. The value of partition is 2. You are using 2 as the first variable. So you have 0 left. You have nothing left. And index, if you look at index, it starts from 0, 1, 2, and 3. Every time you call a function, you add 1. Now the value is 0. You have nothing to partition. So I want to print. And index says you should print 3 numbers. So I'm going to print 1, 1, 2. This is still 1, but you don't care since you are only printing 3 numbers. This index tells you how many numbers you should print. Then we continue this. So the value becomes 2. This is 0. So the function will return. We'll pop this frame. And we come to this frame. Value, you want to increment value to 3, but 3 is larger than left. So you pop this frame also. Therefore, we have only this left. Now you can increment this value to 2. So that's what you get. And you change this to 2. We have print 1, 1, 1, 1. We have print 1, 1, 2. We are ready to print 1, 2, 1. And you notice this. We are changing this to 2. Why is it 2? Because index is 1. And the number you want to partition is 3. The first number you use is 2. So the next number you use is 1. Oh, I think I just stopped here. You'll change this to 1. And then if you change that to 1, you have nothing left. So you print the array, you'll print 1 to 1. I know this sounds a lot of work, but I'm sure it took me longer to write than it's going to take you to read. You should read. And you should read a few times to make sure you really understand. A common misconception, I hope we already talked about it before, among many students is they somehow think when you have recursive call, your call stack will be compressed into 1 frame. That's wrong. Recursive call is the same as any other function call. Every time you call a function, you push 1 frame. Every time the function finishes, you pop 1 frame. one print only. Okay, any questions? Great, the class is very intelligent. Nobody has questions. All right, if you don't have any questions, look at this function. So let's start adding some restrictions. Let's say the restriction is you can use only odd numbers, you cannot use even numbers. What are you going to change? Yes? You have a question?
No, but I can answer that if you want.
Okay, first, make sure everybody understands the question. You cannot use 2, you cannot use 4, you cannot use 6. You can only use odd numbers. What are you going to do? Yes?
If you take the modulus of first with 2 and it's not equal to 0, then it'd be valid, wouldn't it?
Okay, so your suggestion is if first modulo 2 is 1, then you continue, right?
Yeah.
Otherwise, you don't do it. You skip that number. Yes?
I have a question. Could you also, in the for loop at the beginning, instead of first plus plus, say first plus 2?
Sure. That's another solution. You, instead of doing plus plus, you say plus 2. That will do the same thing, right? You start with 1, you add 2, it becomes 3. Okay. Is it good? Do you agree? What happens if you are not, you can only use 1, 2, 3, 4. You can at most use 4. You cannot use 5. Even though you want to partition 15, you can only use up to 4. What are you going to do? What are you going to do? If you can only use 1, 2, 3, 4, so if you have 15, you can do 4 plus 4 plus 4 plus 3. But you cannot do 10 plus 5. What are you going to do? Do you understand the question? Okay. So what are you going to do? Can you speak louder? Be confident. I know you know the answer.
Set first smaller than 4. Set first smaller than 4.
Okay, so make first is between 1 and 4. Since I didn't say it's odd number, so I will do plus plus, right? So your first number can only be 1, 2, 3, 4. Right? You are not allowed to make it bigger. Right? Thank you. If this will can use only 1, 2, 3, and 4. Right? That's the restriction. Some of you may ask, how about I just generate all possible partitions, 1, 2, 3, 4, 5, 6, and so on, and I handle it when I try to print. So that's this one solution. Another solution is here you will say 4 let me say valid equal to 1. Okay. Some of them may ask, how about this? And you print only if valid is 1. Oh, I need a semicolon there. Is that a good solution? Is that a valid solution? Before you print, you check whether any number you use is greater than 4. And if it's greater than 4, you do not print. Is that a valid solution?
that a valid solution? Do you understand the problem? Okay. So where did I lose you? You think it's a valid solution?
Wouldn't it then still run the loop for not valid numbers?
Yes. So the next question, the first question is a valid solution. The next question is it a good solution?
So the valid solution is a good.
It's not a good solution. Why? Because you are generating many partitions and store them away. Your program will be very slow. Right? And that's what we did last semester. We have some restrictions. And if you do it in this way, your program will take a few minutes to run because you'll generate large cases and store them away. So this is okay, but very slow. A better solution is don't generate those bad solutions, right? So a better solution is to do it here. Does this make sense?
Yes.
Okay. So that's why last semester we had something like this, and our solution took a second, and some student solution took a few minutes, because we generate many cases, and then they throw away at the end. For this class, we don't emphasize that much. As long as your program finishes, and we can grade. All right. If you take 3 weeks, then we cannot grade. But if you take a few minutes, it's okay for us. When you go to 368 data structure, if you have an inefficient solution, you get 0 because efficiency is emphasized in data structures. Yes, please.
Aaron told me that for this assignment, if we did that, we'd get 0 on it.
Oh, okay.
Yeah.
All right. Maybe you should not do that inefficient anyway. You should understand the better solution. Okay. We didn't anticipate people to do that last semester, so we didn't make that rule. But you understand the difference, right?
Yeah.
Does everyone understand the difference? What is a better solution? Okay. So now how about this? So I say that's a better solution. We are going to delete that so I don't confuse you. Okay. Now how about I want to have increasing number. Let me put this back into n. If I want increasing number, what should I do? If you use 1, the next number you can use is 2. You cannot use 1 anymore. If you use 5, the next number you can use is 6 or 7 or 8. You can no longer use 4. Once you use a number, the next number has to be bigger. What am I going to do? Okay, so you said, tell me again.
You can say first to array of index minus 1
Oh.
plus 1.
Plus 1. Is that a solution? What? It won't work. Why? If index is 0, so what should we do? Okay, you are pretty close. You are pretty close. Can you help? Do you understand the question?
Yeah.
Okay, can you help? You are very close. But there's something is wrong. Something is wrong. What is wrong? What is wrong?
As you said, you can't, if the value of int is equal to 0.
If int is 0, you have a problem. Okay, so how do you solve the problem?
You can put the question for an operator there.
Okay, so how about this?
I just do this way, okay? How does that sound to you?
If index is 0, the first number I can use is 1. If index is not 0, the first number I can use is the number I used earlier plus 1. How does that sound? Okay? So that is one way to do increasing.
Many people would just write this one,
forgetting for index 0. And their program will do very strange things. Because once you have negative index, who knows what the program will do? It's impossible.
Why don't we do, I don't understand how that would only turn increasing numbers.
Because that sum with index 0. Index 0 means you have not done anything. You can use 1, or 2, or 3, right? So our for loop start with 1. Are you okay with that? For index 0. For index not 0 means you have done some work, right? You have put used a few numbers already earlier. The number you can use now has to be greater than the number you used earlier. So that's why you pass 1. And if you follow this every time, the next number is going to be greater than the previous number. And this is using a property integer, its transitivity. Because if you say index is 4, the number for index 4 is greater than the number for index 3, do you need to check for the number index 2? You don't, because transitivity. If array
is so if array 4 is greater than array 3 and array 3 is greater than array 2, then you know, right? Does that make sense? Does that answer your question?
Yeah.
All right, so we're using transitivity here. Where do you learn sensitivity? In which course? Probably algebra. Right. Where do you learn? Where do you learn sensitivity? Do you know what transitivity?
Transitivity.
Yes. Transitivity says if A is greater than B and B is greater than C, then A is greater than C. Okay. I assume everybody learned that. Right. Now, not everything has that property, right? Not everything has that property. For example, complex numbers don't have that property. In fact, complex numbers you cannot even compare them. Its complex numbers are not ordered. I saw you raise your hand.
Oh, no, I'm just gonna use it.
Okay. Where did you learn it?
I learned in 8th grade geometry.
Okay, geometry. All right. Okay. So those kind of things are useful, right? Sometimes we learn mathematics and say, why do we care? Well, it's useful here. Okay, how about the following? Is it good for everybody? Okay, how about decreasing numbers? How about decreasing numbers? So if you use, let's say you want to partition 10, if you use 6, the next one, if you use 4, the next number you can use is 3. You cannot use 4 again, you cannot use 5. What are you going to do?
very similar. Yes?
Can you just change it to -1?
Which line?
Which line minus 1?
Well, in that line,
This line?
you would make it -1 there.
Okay?
That would be the maximum,
Okay?
I think.
And? Or I'm going to delete this one so we see. Okay.
We need a little bit more. Yeah, that's a good start.
I mean, but so that would be the maximum, so it couldn't go any higher than that. So,
Okay, keep going. I'm listening.
so instead of first equals start,
And?
you would just do first, but then change your second parameter to make first less than start instead of end.
Less than start? Okay, oh, I see. You mean this way?
Yeah, so it's like the maximum,
Okay. Keep going.
and then get rid of the first equals start,
This one will be,
just first,
first has to be initialized.
1.
1. Okay. Okay? We are pretty close. We still have a little bit detail to take till waking up. We still have a few small details to worry. We are pretty close. Any help? Yes?
Can I, in the if condition, at first can I say start is equal to n? Then I
Okay, start equal to n.
Then I say in the for loop first is equal to start.
Which one? This one?
Yeah.
This
first
one?
is equal to start, exactly.
This one, start.
And then first needs to be greater than n.
Greater than n.
Yeah, or equal. And then I decrement first.
Does everybody agree? Oh, very close, very close. What? First greater than 0. What happens if we say greater than 1? You agree with, okay. So, how about this one? Agree? If you have nothing done, the biggest number you can use is n itself, right? Otherwise, it's the number is what is less than the number you have used earlier, so that's start. And then you decrement. Be careful that when you have those restrictions, increasing number, decreasing numbers, sometimes you have no answer. For example, you want to partition, let's say I want to partition 6. If you use the first number is 3, with 3 you can do that. If the first number, you want to partition 6 and you want to do decreasing, if the first number you use, since the first number you can use is as small as 1, right? Once you use 1, the next number becomes 0. So if you want to partition 6, the first number cannot be 1. But you do check. You say, I want to partition 6, the first number I can use, start with 6, and 4, and 5, and 4, and 2, and 3, and 1. When the first number I use is 1, then I have no partition. Does that make sense? So that's the reason you need to use 0 here. If you use n less equal to 0, some people will write that, then you may use negative numbers.
because you think negative numbers are still valid. So you should not use less than. If we have certain restrictions, for example, you want to use, let's say you want to do increasing. You want to partition 5. If you use 1 and 3 for the first two numbers, right? 1 and 3 for the first number, you have 1 left. But you cannot do anything with 1, right? You have, because the number has to be greater than 3. Therefore, you don't have a valid partition if you use 1 and 3 as the first two numbers. That's the reason over there you need to use equal to 0, because once you have certain restrictions, some partitions will be invalid. You only print when you successfully partition, and that means you have 0 left. Yes?
Would it have been bad form, since we already had the increasing code, to just print it backwards?
You can do that, yes.
Okay.
I just want to do an exercise.
Yeah.
So if you have 5 and you have 3 and 1 as the number, then how does the recursion break?
The recursion will try to enter, but you can, if let's say you have 1 and 3, let's say you say 3 and 1, right? You have 3 and 1, since you used 1 earlier, your star will be 0. Then this condition will fail. Okay. Does that answer your question? Alright? I know there's a lot of material here. The code is very short. If you look at the code, it's only about 50 lines of code. But that's a lot of material. You really need to understand the code stack. Go through this patiently. Make sure you understand. Alright. Good luck. I'll see you later.